So for our chapter, we have chapter 2, and in our group we have John, Christine, Carl, Alejandra, Alan, and Abriana. First, we'll be talking to you about the history of probability. So, the Nuova Chronica, a 14th century history of Florence by the Florentine banker and official Giovanni Villani, includes much statistical information on population, ordinances, commerce and trade, education, and religious facilities, and has been described as the first introduction of statistics as a positive element in history. Through neither the term nor the concept of statistics has a specific field yet existed. The mathematical methods of statistics emerged from probability theory, which can be dated to the correspondence of Pierre de Fermat and Blaise Pascal, 1654. Christian Huygens, 1657, gave the earliest known scientific treatment of the subject. Jacob Bernoulli's Ars Conjectandi, Posthumus, 1713, and Abraham de Moivre, The Doctrine of Chances, 1718, treated the subject as a branch of mathematics. In the modern era, the work of Kolmogorov has been instrumental in formulating the fundamental model of probability theory, which is used throughout statistics. Now we're going to talk about definitions of probability. And one definition is: an experiment is an act or process of observation that leads to a single outcome that cannot be predicted with certainty. The next definition is: a sample point or a sample space is the most basic outcome of an experiment, and sample space is the collection of all its sample points. Another definition is an event, which is a specific collection of a sample point, and all possible outcomes are called sample space. A random variable is a variable that assumes numerical values associated with the random outcomes of an experiment, where one and only one numerical value is assigned to each sample point. A random variables that can consume a countable number of values are called discrete. Random variable that can assume values corresponding to any of the points contained in one or more intervals are called continuous. The probability of distribution of a discrete random variable is a graph, table, or formula that specifies the probability associated with each possible value the random variable can assume. In this chapter, we are looking at two operations on probabilities which divide into three different cases. The two operations are additive rule and conditional probability rule. The three different cases are general, mutually exclusive, and independent. So the equations for mutually exclusive is probability of A and B equals 0, and probability of A or B equals probability of A plus probability of B. Another equation is the probability of A divided by the probability of B equals the probability of A and B over probability of B equals to 0 over probability of B, which gives evidence to probability of A divided by probability of B equals 0. For the second case, there are two operations for the general formula, which is the additive rule, and the formula for that one is probability of A or B equals probability of A plus probability of B minus probability of A and B. For the conditional probability, it's the probability of A divided by probability of B, which equals to probability of A and B divided by probability of B. For the last formula, it's going to be the independent formula, which will be probability of A and B equals the probability of A times probability of B. We also have the probability of A or B equals probability of A plus probability of B minus the probability of A times the probability of B. Another one is the probability of A divided by B, which is the probability of A times the probability of B divided by the probability of B. And then another one is the probability of A divided by B equals the probability of A. Now we're going to show you a card that's selected from a deck to find a probability. So say you want to find a probability of an ace, it would be probability A equals 4 over 52, which is reduced to 1/13 because there are 4 aces in a deck. If you wanted to find a probability of a jack or spade, you would put probability of jack or spade equals the probability of jack plus probability of spade minus probability of jack and spade, which would conclude to 4 over 52 plus 13 over 52 minus 1 over 52 equals to 16 over 52 and reduces to 4 over 13.